Hey guys, this is Mr. H again. Hey, I want to do another example of how to interpret slope and y-intercept. So this is from the same packet. This is the second one. It says we have a function below. Um, it's a linear function that shows the total cost of a Dairy Queen ice cream sundae with different number of toppings. Again, toppings is one variable, the X variable, and it stands for toppings. And then the Y variable is total cost. So, um, so if we look at this function, we can see that the total cost, we got total cost here, and then T stands for toppings. Now, immediately you should say, oh, the y-intercept for this one is going to be 350. So that's the y-intercept. Now remember, if we were graphing it, it would be 0, 350. So that means when there are 0 toppings on your sundae, the total cost is going to be 350. So that's what the y-intercept is. When your sundae, has 0 toppings, the cost is $3.50. That's what the y-intercept is. It's always, whenever you're interpreting y-intercept, it's always where the X variable is 0. So 0 toppings, the total cost is 350. So that's what the y-intercept is. If we were looking at a graph, and then we're going to look at a graph in a second, but if we're looking at the graph, it's going to be where the line crosses the y-axis. Now, so what's the y-intercept? Let me create a little bit more space. The y-intercept is the coefficient of the variable, so it's going to be 0.75. So that is basically 75 cents. And so, and remember, that's the y variable. The y variable is measured in dollars and cents. And the x variable, toppings. So this is toppings. So basically, just like we did in the last question, this is saying if we add one topping to the sundae, we're going to increase the total cost by 75 cents. So that's what the slope means. The slope means for every topping that I add to the sundae, total cost, the y variable, total cost goes up by 75 cents. So that basically just means that each topping that you put on the sundae costs 75 cents. So now they told us that Mr. H paid $7.25 for a sundae. So how many toppings did he have? So they've given us the Y value, the total cost. Now we need to find the X value, right? So we're going to use the calculator on this. That's what we're doing. So we just go get the calculator, go to the graph. Let me do this menu 45. And then I'm going to enter the function that they gave us. So it's 350 plus 0.75 cents. We put an X. Remember, we can only graph X's. Press enter. There's the graph. If we want to find the y-intercept, we do menu 51. The y-intercept is 0.350 as we expected. Now all we have to do is put in the total cost for that Mr. H paid. So $7.25 is what I paid. Now you don't see that line because it's up here, but there it is. Now all I have to do is find the intersection, and that's going to tell me the topping. So if I do menu 64, there you go. So that means I put on 5 toppings on top of my sundae, and that's what the total cost was. So you would go to and you would say, Mr. H had 5 toppings on the sundae, 5 toppings. Because each topping was 75 cents. We would take that and we would add it to the plain sundae. So remember, the y-intercept just says when the sundae has 0 toppings. Another way of saying that is if you just went into the Dairy Queen and got a plain sundae with no toppings on it, you would pay $3.50. But then every topping that you add would cost you 75 cents. So that's the rate that you would pay for toppings. Okay. I want to do one more. Um, let's do this one real quick. Um, so here we've got another linear function, and it says this is the total cost to attend the New York State Fair. And if you go on R rides, so the X variable is rides, and the Y variable is total cost. The units for total cost, of course, is dollars. The units for rides, for the X variable is rides. So if we look at this function, it tells us that the y-intercept is 6. It's going to be $6. And what does that mean? Well, it costs $6 if when we with 0 rides. So we haven't even written anything. So the y-intercept is, it costs $6 and we've gone on 0 rides. So basically what that means is that's the cost to get into the fair, because we haven't even gotten on any rides and we're still paying $6. So remember, the y-intercept is always where the X variable is 0. So basically we paid $6 and we went on 0 rides. Next thing, the slope. The slope is $1.50. So let's put the units on there because this is what we're going to use. So it stands for $1.50 on the top. That's the Y variable. And on the bottom, it stands for rides. So basically, it's saying if you go on one ride, the total cost, your total cost is going to go up by $1.50. That's the slope. So every ride that you go on, every ride that you go on, increases your in total cost by $1.50. And all that means is every ride is $1.50. Now, they told us that the total cost was $21. That's what I paid. So we're going to do the same thing. We're going to go in here and we're just going to graph it and find where they intersect. And that's going to tell us the number of rides or the X variable. So I'm going to go menu 14. Let's get rid of this. And then we're going to go tab. We're going to put in the function. Remember, we can only put in x's and then +6. 0.00, press enter. There's our function. That's the function for attending the state fair. And then we know that I actually paid $21. So I'm going to put 21.00 here. And then, of course, you don't see it, so we got to go find it. You can zoom out, but here is the intersection, and that's going to tell us how much I paid. So if I move this, do menu 64, and I go here, and I pull it, it's telling me I must have gone on 10 rides at the state fair. That's why my total is $21. So you would come to your sheet here and you say, Mr. H went on 21 rides, or actually not 21 rides. It went on 10 rides. And so his total cost for 10 rides was $21. Boom, done. Okay, that's all you guys are doing. I'm going to stop this and post it.